Ladies and gentlemen, thank you for your time. Thank you for inviting me to this interesting conference. First of all, I would like to explain our product. This is because it's a rather complex product, but its mode of operations must be fundamentally explained in order to properly assess its significance for the future of renewable energy. 2G is the technology leader in so-called heat and power plants, CHP for short. In this technology, a gas engine drives a generator. On the input side, our gas engines can process virtually any type of gas that contains even a minimum amount of energy. That includes natural gas, biogas, all kinds of special gases such as landfill gas, mining gas, but also pure hydrogen. In this context, it should be noted that we are the only manufacturer in the world who already has a fully hydrogen-powered CHP in its regular product range. I come back to hydrogen later, promised. On the output side, we have achieved overall efficiencies of up to a very impressive 92%. Our machines provide electrical and thermal energy at the same time. The electrical energy is either fed into the public grid or consumed on-site. The thermal energy can be used in many ways. The easiest way, feeding it into a district heating network. However, this way is rather seldom. Our expertise lies more in on-site utilization, be it for high temperature applications in industry, be it as heating for real estate, but also in connection with absorption chillers or steam generators as used in hygiene sector of a hospital, for example. With our know-how on both the input and output side, we strongly differentiate ourselves from the traditional engine manufacturer. Companies such as Wärtsilä or Caterpillar usually concentrate on one type of gas or on only one application for electrical and thermal energy. We offer a power range of 20 to 4,500 kilowatt with an average size of 350 kilowatt per power plant. The traditional engine manufacturers are well above this size. Wärtsilä again supplies CHP units that are 30 times larger, but with which entire city districts are then supplied with means of, in our eyes, simple district heating. With our high-tech products, we have been on the market for exactly 25 years with growing success. This leads me to the next page, which I cannot spare you. As already noted, we were founded in 1995 and are based in Northwest Germany. Our IPO was in 2008. Today, we have a market capitalization of around 400 million euros. The majority of the shares are still held by the two founders. Approximately 47% is in free flow. For the current year, we are targeting sales of 240 to 260 million euros, which we will achieve with approximately 650 to 700 employees. Meanwhile, we have delivered about 6,500 CHP in more than 50 countries worldwide. If you add up the capacity of all our power plants still in operation, you can see how important they are for the mainly European electricity market. Our power plants have an electricity capacity of about 1.8 gigawatt, which is equivalent to a nuclear power plant. For example, Forsmark 3 in Sweden provides 1.2 gigawatt. We are definitely the global technology leader for hydrogen in CHP. And in the world's largest and oldest CHP market, namely Germany, we see ourselves as the general market leader. So let's look at some less dry facts. I've brought you some original quotes from last year's Power and Renewable Energy Conference. Already last year, and presumably also in the previous years, the discussion repeatedly revolved around the enormous potential offered by wind and photovoltaics. Here are three statements. The use of infinite resources. This is our future. Solar and wind expected to provide 50% of all power globally. And finally, wind as an essential part of the future energy system. If you have also heard these statements and they seem logic to you, then you have done nothing wrong. The potentials for wind and PV are certainly huge, but wind and PV will certainly not be the only two pillars for an energy transition. They absolutely need a baseload capable counterpart. a fact that is well known among some engineers, but so far insufficiently taken into account in the political discussion. Please follow me on a short journey through figures and statistics. In the end, you will see that wind and PV have a soft flank. The good news at 2G, we care for a better future. Here you see an illustration of the total energy consumption in the EU 27, sorted by the countries with the highest consumption. Not surprisingly, Germany is clearly in the lead with 2,500 terawatt, which has to do with the size of its population and also with its high level of industrialization. In my further remarks, I will therefore refer to Germany. On the one hand, it's obviously our home market. On the other hand, there are good statistics available for almost everything. But please assume that most considerations that apply to Germany in terms of energy issues also apply in the same or a similar way to many other countries in Europe. France is an obvious exception with its extremely strong nuclear technology, but Italy and Spain are definitely comparable. Let us now turn to the various consumer groups. I've taken the trouble to separate the consumption for electricity from the 2018 overall consumption figures. More recent figures are unfortunately not available. By this exercise, final energy consumption without electricity is shown for all four sectors, which are transportation, industry, private households, and the service sector. So, what do we see? With or without electricity, the transportation sector is the largest energy consumer in Germany. Out of 740 terawatt hours shown here, 95% is consumed in the form of mineral oil. The situation is different in the other sectors, industry, private households, and service sector. Here, the vast majority of energy, after subtracting electricity, is consumed as thermal energy. This is a fact which we should keep in mind when discussing renewable energy. Electricity consumption over the entire German economy stands at 513 terawatt hours. Hence, electricity in Germany accounts for only 20% of total energy consumption. Let's now look at where the 530 terawatt hours of electricity consumption in Germany came from. Please note, for the 2018 electricity consumption, I took the projected source distribution of 2020. This approach is in favor of wind and photovoltaics because of the additional capacities installed during the last 2 years. So wind is actually the largest source of electricity. It provides 139 terawatt hours, very close behind coal with 128 terawatt. It's followed by nuclear energy with 67 and gas with 62 terawatt hours. Photovoltaics comes in at number 5 with 51 terawatt hours. If you add up wind and PV, you get 190 terawatt hours, which corresponds to 37% of annual consumption. All other energy sources add up to 323 terawatt hours. These other sources are all baseload capable, which means they are available at the push of a button and are not dependent on the weather. Now, one might think that an annual average distribution of 37 to 63% would already be quite favorable. Let's take a closer look at 2 winter months. For this purpose, I analyzed the months of December. However, November and January look basically very similar. In December, wind can still hold on to the second. PV, on the other hand, drops sharply and is now close to the perception limits, if you like, with only 1 terawatt hour. Wind and photovoltaics together reach only 27% of the total electricity production in December. Winter months are always very problematic for photovoltaics. Misty weather is even worse. No sun and no wind. And anyone who has been to Tuscany in Italy in winter knows that misty autumn and winter weather is by no means a Nordic issue, not at all. From December, we could now go further into details and look at some individual days and later even at single hours. I've spared myself that and concentrate on some general observations regarding the just finalized year 2020. So, the year 2020 had 8,784 hours. On 722 hours, wind and photovoltaics contributed less than 10% of hourly electricity production. That's basically next to nothing. Now, you might be of the opinion that this is a winter issue. Unfortunately not. We also have serious outages in the summer. In the entire month of July, we saw 87 hours out of 744 hours in total, where wind and photovoltaics actually contributed less than 10% of electricity. If I do pick out a single day, let me direct your attention to June 16. On this summer day, all wind turbines together produced an hourly average of only 1.1 gigawatt out of a capacity of 59.8 gigawatt. This results in a lousy utilization rate of 2%. Photovoltaics had a utilization rate of 13% on this summer day. Also not fantastic in my eyes. If you had the idea that wind and photovoltaics should replace the entire nuclear and fossil power production on this summer day, Germany would have to increase the number of wind turbines tenfold and almost double the number of solar panels. Without a question, a very ambitious idea. Now, to make things a bit more complicated, Germany, like many other countries, has decided to drastically reduce coal firing. What makes this decision unique, to put it into mild words, is that Germany will simultaneously phase out all nuclear power and shut down numerous coal-fired power plants in parallel. All German nuclear power plants contributed approximately 67 terawatt hours in 2020 and will be completely shut down in 2023. At the same time, coal firing should be reduced by approximately 96 terawatt hours by shutting down capacities of approximately 11 gigawatt. Both effects together cumulate to 163 terawatt hours and required an 85% production expansion of annual wind and solar power production. So the magic question for Germany is, given the consumption pattern of 2020 and the weather conditions of 2020, will the future power plant fleet of 2023 be strong enough to cover the needs of electricity? Let's assume that all existing natural gas power plants, including the few new ones, which will go live until 2023, run during the entire year with maximum capacity. And let's also consider the new additional NordLink cable connecting Norway and Germany. Still, Germany faces a severe situation with approximately 1,400 hours with power supply bottlenecks, including almost 500 hours with a deficit exceeding 2.5 gigawatt. We have prepared a graph illustrating these figures. You can see that, especially in the winter half year, the electricity supply situation in Germany will depend to a large extent on imports of foreign electricity. For more than 6 months, the power supply in Germany, and thus also in Central Europe, will depend on the weather. The weather should be as clear as possible and, above all, consistently windy. Take a look at December. To close the deficit on December 9, adding more solar energy would not be a solution at all, since its utilization rate on that day was only 1%. And for wind energy, it would be necessary to build about 80,000 additional wind turbines of 3 megawatt each in Germany. Again, a very ambitious idea. If you look at the European neighbors, you see that not one country had even a single kilowatt hour for electricity from renewable sources in surplus. Denmark, for example. Denmark is a small electricity producer in Europe, but naturally comfortably equipped with wind turbines. Denmark produced a total of only a good 7 megawatt at all that day in January, even taking all fossil sources into account. In general, Germany's electricity deficit will be so large that practically no country in Europe will be able to provide sufficient and permanent compensation. The largest electricity exporter in Europe is France. but in France, as you probably know, many buildings are heated with electricity. As a result, France is already a net importer of electricity on quite some winter days. France too is therefore no longer a supplier of electricity for the winter half year. So basically, periods with missing wind and PV harms the energy production in all neighboring countries at the same time. In addition, the European neighbors will reduce their conventional power plant fleet as well. They will reduce significantly by approximately 100 gigawatt of capacity in the next few years. The situation will therefore become more severe, at least in winter. I mean, it cannot be a solution that all European countries rely on electricity imports from the neighbors all on the same day, meaning when PV and wind don't deliver as they should. In the end of the day, the electricity has to come from somewhere, even in the end of a misty and calm winter day. Reliable power supply will become a scarce commodity in Europe. Please note, we are talking about a scenario that could occur 500 working days only, 500 working days from today. In Germany, we expect a new federal government this fall. This federal government will probably be based on a coalition of conservatives and ecological parties. And this federal government will basically stick to the, in my eyes, overambitious roadmap to phase out coal and nuclear at the same time. Therefore, replacement power plants will be necessary in Germany. These power plants will probably have to meet the following criteria. They must be cleaner than coal-fired power plants, that's logic. They must be available at short notice, because the new German government will only have one more year left before the national power supply becomes critical. The new power plant must be able to carry base loads. That's, after all, the core problem. The new power plant must be available in large numbers and with large capacities from 2023. And ideally, these power plants should also fit well into the even much larger task of decarbonizing the heat sector. When you go through all these criteria, you find that only CHP plants fit to this list of requirements. And that means CHP plants up to a maximum size of 10 megawatt, since there is no time buffer left for installing larger power plants, which require substantially more cooperation from all stakeholders. You may now be asking yourself whether and to what extent 2G can benefit from this situation. Well, we see it as follows. 2G has a product portfolio that meets all conditions and prerequisites mentioned a few minutes ago. 2G is already a globally active market player, unlike many other competitors who only have a small international footprint. 2G has already developed reliable and traceable plans to increase its annual output from about 200 megawatt to 500 megawatt, if necessary, in the short term. 2G has the most comprehensive competence for all types of gas, which means on the input side, and secondly, all types of applications, that's on the output side. We are thus much better prepared for all developments than most other suppliers who are typically specialists only on one side of the CHP, input or output. And finally, 2G is without question the technology leader with regards to hydrogen. 2G has unique competencies in this area, not only on national level, but also on global view. We already offer a complete product range of serious machines. In this context, we have collected experience with hydrogen dating back to 2012, when we supplied a first hydrogen CHP to the new airport in Berlin. As you well know, probably, the airport only went into operations after many years of delay, so the hydrogen CHP never went into continuous operation. But we took the advantage of the time and introduced a successor model in 2018. Since then, we have sold 5 CHP units. I've listed the projects here once. The interest is huge, so more orders are under negotiations. Last but not least, and that is really quite important, 2G is the only CHP manufacturer worldwide that can guarantee that the conventional CHP delivered today can be converted to hydrogen at a later date, if cheap hydrogen one day is available in large quantities. CHP from 2G should therefore not be seen as a temporary bridge technology. On the contrary, hydrogen-powered CHP units have the tremendous potential to become the dominant backbone of the European electricity and heat supply. Let me summarize. We are aiming for sales of 300 million euros in 2024. We certainly see further growth potentials in later years due to the bottleneck situation I've described in detail. We will then also achieve an EBIT of 10%. The equity ratio today is just under 50%. We will keep it that way in the coming years. Cash flow will continue to grow reliably as we have a service business that is growing in itself. Service already contributes around 1/3 of total sales. We also operate in a down payment culture, as our customers traditionally pay for 90% of equipment before delivery. We aim to achieve the 2024 revenue targets without significant capex. And finally, I can announce that we have been ESG certified since December 2020. The renowned agency ISS subjected us to an audit, which we passed. Keep us on your radar screen because we combine fascinating technology with sound business model. Thank you for listening.